So welcome to Nelson Irrigation Technologies LESA presentation on our LENA tools for these applications. My name's Steve McCoon and I'll be moderator today. I'm a territory manager here at Nelson Irrigation based in Walla Walla, Washington. I have been here for about 24 years. Jason Hester will be our presenter today on this topic with a lot of experience. Jason's been working with LEPA and LESA systems for about 27 years of his career thus far, arranging everything from the installations, parts sales, all the way to store management. So he's got a lot of experience and successes and lessons learned through these LEPA and LESA systems over a long period of time. He's a certified irrigation designer and certified agricultural irrigation specialist with the IA. For 7 years, he's been a Nelson Irrigation territory manager covering Texas, Oklahoma, and parts of the southwestern states here in the United States. And he's based in Lubbock, Texas. So Jason, with that, I'll turn it over to you.
All right.
For us today.
Great. Thank you, Steve. Appreciate that. Thank you, everybody, for joining us today. We appreciate you taking a little time out of your day to spend with us, and hopefully we can teach you something. We're going to talk a little bit about LEPA, LESA, and I know a lot of you probably know what LEPA and LESA stands for, but we're going to teach you a new term called LENA. And what we call LENA is low energy, low elevation Nelson Advantage. And so we're going to discuss a few of the products that we have to help you with your LEPA and LESA systems. But first, I'd like to get into what the NRCS defines LEPA as, and we'll start with that first. So LEPA stands for low energy precision application. So you'll see here you have a pivot or a linear running. You'll have a gooseneck and a hose. Then you'll have some sort of LEPA head or a bubble plate or a bubble pad. It's going to be 18 inches or less of ground clearance, or you can also, if you see on the right here, drag a hose. You'll also notice that it's got furrow dikes in it, and so what that does is try to trap some of that water on the field, because when we are doing LEPA, the application rates are fairly high in some scenarios. There's a few other specifications we'll go over. This is coming from the Natural Resources Conservation Service here in the United States. And they define it as, they ask the grower to plant using furrows or beds. That way you can drop your water right in between the beds. And pivots must be planted in circles. And if you're running linears doing LEPA, you have to run your beds parallel to the wheels so you can drop your bubble or your hose down in the furrow. Can't have much slope on a LEPA system. It's got to be less than 1% over 50% of the field. You've got to have some way of basin storage, such as furrow diking, to try to keep some of that water on the field. Not allowed to spray on the tower wheel, so you'll be bubbling right next to the wheel, and usually wheel tracks are minimum, if any. We usually design these machines at 10 pounds or less, a lot of 6-pound regulated machines, and a lot of close spacing on the LEPA systems that we do in my area. So here's a few products in action. On the left here, we've got Bubble Wide running in some corn. We've got our Bubble Down product. That's a cotton field right outside of Lubbock here. And then we've got some of our drag hose scenario. So you'll see in the one on the right, they're dragging a hose. They also have a sock on it. And what that does is kind of help with the erosion of the water coming out. It kind of diverts it a little bit. Then you'll also notice the furrow dikes on that picture where they're trying to trap some of that water and keep it from running off. Oh, yeah, so there's some benefits to LEPA, a lot of benefits, but there is some potential problems. So some of the benefits, of course, we're going to have less evaporative loss and less wind drift because we're bubbling and we're dropping straight down onto the ground. We're not going to lose any to the wind. we are having more precise placement of water because we're dropping it directly on the ground and it's going straight into the root system. It's going to be higher efficiencies because of the less evaporative loss and wind drift. We are in certain scenarios get deeper infiltration of the water into the soil. We do have some water and energy savings because of LEPA, because we can run on some lower pressures, because we're not having to throw water and get any kind of distance out of it. And then of course no drift, so you do save some water and possible energy savings. And then of course less wheel tracks because we're not spraying water on the wheels. Some of the problems with LEPA can be when we are putting it out on in a bubble or a hose or even a bubble wide, the application rates are pretty high, especially with higher flowing machines, the GPM per acres in the higher range. You can have some issues with runoff. Can cause some problems, and also there's no way to cool a plant if you're bubbling in the row or dragging a hose. So some areas like to have the sprinkler cool off the plants a little bit. It can be problematic for pivots with terrain. That's why they don't want you to have any slope in the field, but I know there's systems out there running LEPA on some slopey ground, and so that can run on you a little bit. And if the soils are a little tight, that can cause some running too with high application rates. Things that can help with that, of course, is having some residue behind and no-till and strip tilling, stuff like that can help hold that water on the field. And also, you're going to have some sort of spray plate on there to help germinate and chemigate when that time comes. So that's that for LEPA for right now. And so let's move into LISA. LISA is defined as low elevation spray applicator. So everything's pretty similar to the LEPA. The only thing is we don't have to do the furrow diking, and we can spray it out of a nozzle and not have to bubble or drag a hose. And here's a few more specifications for LISA. When you do a LISA machine, you're not required to plant in circular rows or on a linear. You can run your rows perpendicular with your linear if you'd like. Slopes, you get a little extra slope on LISA because we are getting a lower application rate, so you can take it up to 3% on more than 50% of the field. They're not allowed to run water off in those LISA applications, and most of the ones that we design in my area, any LISA stuff is usually on a 10-pound regulator. You can run them in 6-15. Mostly it's 10 in our area, and it can work at 6 if you got some closer spaced sprinklers. Here's a few of the LISA products that we have. We have an orbiter running on the left here. That's an off-axis sprinkler. And then we have the accelerator in the middle, and that's a rotating product, high uniformity. And then a fixed spray plate on the right. And that one is would be our lowest uniformity out of our LISA products. But you'll notice on that one we have a brown spray plate, and I'll talk a little bit about that plate here in a little bit. So let's go over some of the pros and cons of LISA. There is some possible problems with LISA. When you're spraying in canopy, you can have some interference and with your crop getting in the way of your sprinkler and not getting the distance you need on your sprinklers. There's ways around that by just putting them a little bit closer. That helps. We get less precise placement of the water, of course, because we're not dropping it straight down in the furrow. The efficiencies are lower on LISA than LEPA. And we're not getting as deep infiltration because we're not dropping it right down into the furrow. A little bit higher energy in some cases because we usually do run a 10-pound reg or a little bit higher pressure on these, so that can cost a little bit of extra energy to build that extra pressure. And we do get wheel tracks because we are spraying on the wheels at times. There is ways around that. We can put boom backs on it or put a bubble wide or a bubble down right next to the tower, first couple drops next to the tower, and you can still get a decent pattern with the bubble wide but not throw it into your wheel. Some of the benefits that we get with LISA over LEPA is our application rates go down. There is going to be a little less runoff because we are having lower application rates. More cooling for plants, so if that's a concern, then LISA would be a good option to be able to cool your plants off. And if you have terrain and tight soils, you're going to want to get that application rate lower by having a sprinkler that throws it a little bit further. And then of course we're going to be able to germinate and chemigate better with the spray. So what we'd like to ask you is, which products do you usually use when you're using the LEPA Lisa system, if you have been using one? And while you are answering that, I'll kind of go over a few of our products here that we call LENA. So low energy, low elevation Nelson Advantage. These are some of the products that we have. We got the bubble wide here on the left. We got bubble down. We also have the drag hose connection for all of our sprinklers. We have the accelerator, which is one of my favorite sprinklers, and I sell a lot in my territory. And then we have the converter, which allows you to have a high uniform germinate chemigate product, rotating product that can be carried on the pivot with a bubble wide and a bubble down option. So you get 3 options, including a rotating high uniformity product, all riding on the machine, which nothing has to get carried in and out of the field. So I hope you all got all them answered. We'll move on to a little history of Nelson. So in the mid 90s, Nelson released the 3TN nozzle. At that time, it was the easiest changing and cleaning nozzle on the market. A really good product that lasted a long time for us. And like I was talking about earlier on that brown multiple trajectory plate, we tried to come up with something a little different than just having all the streams coming out at the same trajectory. So we designed these brown and orange plates to have multiple trajectories to keep you from having as much stream collision. And it also can help to lower the instantaneous application rate on it because of the multiple trajectories, and get a little better uniformity. So just try to do something a little bit better with sprays than we can. And 2015, we released the 3030 series, and we call it the 3030, and it has a nozzle system we call the 3NV nozzle system. And now we definitely have the easiest to clean change nozzle sprinkler on the market. And what I want to do is kind of run a little video here to show you exactly how this product works. So this is a cotton field right outside of Lubbock, and this guy has drops on every other row, bubbling in the rows. And you can't see the diking, but he did have diking in there. So he's got it. We were out towards the end of the machine, so now you can see a dike right behind there. So we were on the higher application rate of the machine. And so this is a bubble down mode. So we're spraying in the back of a spray plate, but you'll notice he has the accelerator and the converter riding along with him. So all that is in the field, ready to go whenever we need it. So then we get to how the operation of the nozzle is. You can turn it off, so it's a built-in valve. You also have a place to inspect the nozzle to see if you have anything jammed up in there. But for the most part, all you have to do is invert it and blow the trash out and turn it back to on, and it's ready to go. But we also have a built-in line flush that you turn all the way to the right. That way you can blow out any trash that might be getting ready to plug the nozzle. Usually when I've cleaned nozzles out, there's always something coming down after. It's good to blow it out before you switch it back. So now, as you can see, he's flipping to the accelerator. So this is what you do in the beginning of the season. Use the accelerator to germinate, get your crop up, and then later on you can switch to bubble down or bubble wide. All hanging on the pivot out in the field when you're ready to go. So I want to talk a little bit about the accelerator. Like I said earlier, this is one of my favorite sprinklers. I pretty much sold this exclusively when I was selling pivots. And it's a kind of a hybrid between the rotator and a spinner. We have, in the beginning, when the nozzles are smaller, this thing will spin a little bit slower. And then as the nozzles get bigger towards the end of the machine, it spins faster. So what that does is it allows for optimal throw and then keeping the droplet characteristics the way we want them. And so this thing has been in action for 18 years, and I I love it. Most anybody that puts it on loves it. I have no complaints about this particular sprinkler. Um, it is designed for in canopy irrigation. It does operate from 6 to 15 pounds. Most of the packages we do in my area would be at a 10-pound regulator. We would like to see these regulated. Um, 3-plate design. We have an up top navy, and then we have a low angle maroon, and then a high angle gold plate. So let's talk a little bit more about this converter. I really love this product because we can hold the bubble wide, and then on that we hold 2 caps on there. We got a bubble wide cap, but nothing on the back side of that cap, and then we have the converter and then an accelerator. So you can germinate with the accelerator, and that gives you the advantage of having a rotating high uniformity uh, sprinkler instead of a spray plate. You get something that's better to get a better germination and better distance and lower application rates in the beginning of the season to keep your soil intact and not seal it up if you have some high flows. And then when you get the season, you get on with the season, the crop's up, you can switch to bubble wide or bubble down, and nothing has to get moved in and out of the field. It's all hanging there for you. So we get those 3 options: bubble wide, bubble down, and accelerator, all built in one. And so, of course, the accelerator does a better job in uniformity for germination and chemigation than a spray plate. So that's what we like about that. The only product on the market that has it. Another exciting plate for me is the bubble wide. This one has been a huge hit for us. This plate is designed to reduce the energy coming out of the nozzle by changing the flow direction of the water. We turn it twice inside that plate. We switch directions twice, and we have large grooves to um, help keep it from misting and fogging. So, um, and it takes most of the drift. If you're out standing next to one, it's just not drifting even when the wind's blowing. Really, a lot of wind. And so when you pair that bubble wide with 6-pound regulators, it can't be beat. There's just no drift whatsoever. Um, it can also be, this plate can be used for germination and chemigation in cases. So it's actually working for guys not to have to switch it. They can run bubble wide the whole season long. It is the best wide pattern low drift bubble product on the market. So like I said earlier, we do have an option for drag hoses. We have a cap that can be flipped over. One side it fits to the spray accelerator body. Flip it over, it fits on a rotator spinner body. So if you have some spinner or rotator packages that you want to actually switch to drag hoses, we have that option. And then you just attach a 3/4 hose onto it, drop it down in the furrow. Then you can also add a sock to help reduce erosion if you'd like to drag socks. I just want to hit on a couple more products that we have. They're pretty new. Our gooseneck that we just recently released. It's a high efficiency, high capacity gooseneck. And one of the favorite parts or features of it that I like is having a molded male thread. It makes it easy for the installation crew to put it on. And we also have just recently released this coil weight. Inside this is a molded male barb, and then there's a galvanized spring slid on top of it, and then we have this plastic cover on top. So what it does for you is it eliminates you having to buy one fitting there, so you don't have to buy your male barb for the bottom of your hose, and you also get a weight built in, and it weighs 1.25 pounds when we're all finished. So a really neat product. A lot of guys are really liking that. So what I'd like to move into is a conversation that I had with this farmer named Austin Miller. He's an organic grain alfalfa farmer, and he farms in multiple Southwest states and farms a lot of ground. And so I kind of want to go over this picture on the left here. You can see that this package on the left was 6 foot off the ground. It's 10-foot spaced, and there's no regulators on it. So it's probably got 30 to 35 pounds on it. So as you can see, it fogs pretty good. And I don't think there was much wind that day either. I have been up there when the wind blows, and most of that's blowing off the field. And so in the right picture, he has switched to D3030 with bubble wide only. So he has bubble wide and bubble down is the only two options he has on that, and a 10-pound regulator. And so you can see on the right there what we were talking about earlier with having high application rates. You can see him puddling there, but he has ways where he manages that puddling and changes flow rates and different things to be able to alleviate the runoff. In the If he has tighter soils, he can change some of that stuff to keep the water from running off. So I'm gonna move on and let him visit with you a little bit. Visiting with Austin Miller. He's an organic farmer out of multiple states, and mainly grain and alfalfa is his majority of his crops. So Austin, we just wanted to ask you a few questions and see what you've experienced with LEPA. So what were the challenges you were facing that caused you to look at LEPA irrigation?
So, like I think most farmers in the Southwest and a lot of the world practically, we're facing a shortage of water, and we just try to do everything we could to improve our efficiency. We've fought with wind drift and evaporation and crop loss and erosion, and just a lot of the struggles that everybody's facing is what's pushed us to invest and learn and do everything we can to improve our water efficiency.
Okay. And what crops, you said grain and alfalfa, but what particular crops do you normally grow?
We're growing wheat, barley, triticale, involved in a little bit of corn, not real hands-on directly, but indirectly, corn as well. Okay. But primarily most of my farming's in Colorado with alfalfa and grains. Okay. I know you tried the bubble light on your new packages, and I just had a question on it. Were you able to germinate any of your crops with the bubble light? Yeah, we've actually had really good success germinating our crops with the bubble wide. I was a little bit skeptical at first. We even had some of our first systems that we had them designed to have a germination plate on the back that we thought we'd have to go through and flip them to that plate. And we started out that way, but with a little bit of time, I kind of, did a trial and sprouted a few with the bubble wide. And, the way I've seen things right now, I really wouldn't hesitate to go from germination all the way through the growth stages to finishing a crop, start to finish with bubble wide. Bubble down, we have a lot of experience with it now too, and it's a little bit different system, but we have had good luck actually germinating with bubble wide. Yes.
Outstanding. Great. And so, as we know, when we're doing the LEPA system, our application rates are really high. And so soil composition is a big deal. And so what are you doing to adjust for the different soil types that you're watering when you switch to a LEPA system?
So kind of depending on our crop, soil type, our elevation in our field, we have played with our pressure in the systems, regulators, our application rates, we'll speed them up, slow them down. We've adjusted our gallons per minute as well, trying to match those rates to the ground to be as efficient as we possibly can. And when you get a lot of water, and it's a great thing to get it on the ground, there's some concerns at times about runoff, but I've had a lot better luck just trying to capture that water and pair up our watering with our soil conditions and utilize that water as best as we can. And knock on wood, we've had really good success with it.
At least that way you're getting it on the ground instead of out into the atmosphere, right?
Yeah, exactly. I'll deal with runoff. It's a great problem to know that you're getting your water on the ground, and we can capture it and keep it in the field. We can adjust our application rates, or we can kind of, if it was a row crop, you can dam up the ends or something to keep it in there. But we really haven't had much trouble. A little bit on the edge of a slope. When you get a lot of water on the edge of a slope, it's going to run a little, but we adjust. With our irrigation technology now, it is not a big deal to speed up or slow down a sprinkler. I mean, you can basically program it directly into most of them now. You have a hillside you're dealing with or something. It's a good problem to have, and one that I feel that we can address quite easily.
Great. Well, I only have one more question for you. So what benefits did you see from all the conversions you've done, just kind of broadly?
So we've converted a pretty significant number of systems to LEPA, and we're still in the process of doing more. Benefits that I've seen, drop your nozzles down low and get the water on the ground, and wind drift. We have drastically reduced our wind drift. I mean, I've got pictures standing in a field with 50, 60 mile an hour crosswind, and you see basically no wind drift whatsoever. You can stand right behind the machine and carry out a conversation. The soles of your feet might get wet, but other machines, they're high pressure, more spray type nozzles. You can see that fog drifting halfway across a circle, clear out of the circle. Wind drift has been great. We have drastically reduced that. The other big component has been in our evapotranspiration figures, our loss to our canopy evaporation. When you get a fairly tall, thick crop and you run a sprinkler over it, you hang an incredible amount of water on that canopy. And if you were to go walk through those, a lot of times from the knees down, you're soaking wet, clear to your socks. And all of that water, the majority of that's going to be evaporated and lost. With the LEPA systems, especially the LEPA down, we're able to get that water to the ground and keep it off of the canopy. You can walk through some of those crops right behind the sprinkler. And yeah, there'll be a little wet strip right below the nozzle, but for the most part, those crops are dry. The water got to the ground, we didn't hang it up on the canopy, and that's water that we won't lose. So between those components of minimizing wind drift, minimizing our evapotranspiration component from the canopy evaporation, we are able to, I think, capture a lot more water. We get a lot more water directly puddled or ponded on the ground. So we're able to push our water down deeper, easier. If you run other systems for a longer time and more rounds, you can get water down in the ground, but we're able to do it quicker and with less water than we were before. We're able to penetrate water down to deeper levels where we can hold it better and make use of that water more beneficially. I think those are our biggest benefits that we've seen so far. Yields have hung in there. I feel like in some fields we have improved our yields. In some we've kept our yields the same, but with less water. So that's a win. But in a lot of fields, we have kept our water the same or less and had as much or more yield. So, in today's world where water is a big concern and a big problem, we can grow a crop with less water. It's a home run for us. And, we haven't had much trouble with excessive nozzle plugging or some of the issues guys worry about. We've found it to be no more maintenance than other systems, if anything, less. We've been able to space them from anywhere from 30 to 60 inches, depending on our system and how we want it to work. We've had good luck with both the bubble wide and the bubble down. So we're excited about it. We think it has a very positive future, and we're hoping it has a very positive use in our farming operation in the future.
Well, I hope you all enjoyed that video. He's a neat guy and a really good farmer. And so we just wanted to ask y'all, what is the biggest obstacle y'all face in LEPA and LISA? And while y'all are answering that, I wanted to finish up with what we suggest on some configurations when you're using the bubble wide. When you're 40 inches or closer on your drop spacing, 6 pound works great. Can use 10 if you'd like, but 6 usually reaches and gets everything wet and does a good job. And you can go a little bit lower when you have closer spacing on your sprinklers. So 2 foot or less works fine. When we get that if you're using bubble wide on 40 to 60 inch spacing or higher, and well, we don't want you going any higher than 60 inch, but most of it will be at 60 or 30s or 40s. So if you're out at that 5 foot, then I suggest my guys and the farmers in our area to run a 10-pound regulator, so we get a little bit further diameter, and we can, you know, throw the water a little bit further. And then on top of that, if you bring it up to 3 or 4 feet there, if you're trying to, you know, if you're doing just straight bubble wide and you're that far apart, you're going to need to get some distance to get some good coverage. So with that, we've already wrapped it up, and I thank you for your time, and feel free to contact me and for anything you need, and we'll open it up for questions.
Thank you, Jason, for your presentation. I do have a few questions sent in. We probably won't get through all of them, but one asked, how can I close a Nelson nozzle? And this has to do with the 3NV nozzle and it being a valve downstream of a pressure regulator. That the fact that these flow rates are and the closing speeds, that in this instance with the 3NV downstream, it is okay. I'll just answer this one
Okay.
quickly. It's okay to have that valve downstream of pressure regulator. We're good in that space. Other questions for you. Of the LENA products for LEPA and LEASE applications, which have the lowest application rates?
So the lowest application rate would be the accelerator because it is a rotating product, and we get further throw out of it than we would a spray plate.
Okay.
Better uniformity.
Is a LEPA system more expensive than a standard sprinkler package?
Yeah, most of the time it will be if you're in that close spacing. If you're doing a LEPA on every other row, then at that time it probably wouldn't be more expensive. But if you're dropping your spacings down to 30 and 40 inch spacings, then for sure you'll have more drops, more goosenecks, more regulators, everything. You'll just have more product to put on the machine, so it can be more expensive.
Okay, and we'll squeeze one more.
Okay.
How widespread do you see dammer diking?
Yeah, it used to be a big deal back when we had a higher application rates and more water in the panhandle here. I don't see it as much anymore. It's not for most of the time nowadays. It's for keeping rainwater on the field so you can trap it, because around here when it rains, it's a big rain, and they try to catch some of that rain on there. And it does help if they're doing some LEPA stuff, but it's not as widespread anymore as it used to be, because our water level has dropped and a lot of the machines are running pretty low gallonage.
Okay, well, with that, we'll go ahead and wrap up. Jason, again, thank you for your time. Thanks to everyone who attended today's webinar on the LENA products for LISA and LEPA applications in the field. Thank you for your business. Thank you for your time on behalf of Nelson Irrigation and Nelson Irrigation Technologies for these webinar series. Thank you for attending. Have a great day.
Thank you.